Today we are going to see a new data structure called Fenwick tree. A Fenwick tree is generally used to calculate a prefix sum, or we can say a sum of a range. For example, this data structure is generally used to calculate sum of range, as I said. For example, if we want to calculate sum from 0th index to 7th index, that is here 1 to 8, it will be easily calculated through a Fenwick tree. Let's see how. Here we are having an array A with elements indexed 1 to 14, and we are having another array T where the sum of a range is stored. For example, at the index 1, 1 is stored. At index 2, from 1 to 2, what is the sum? 1 plus 7, 8. 8 is stored. And at index 3, from 1 to 3, what is the sum? That is 7 plus 3 plus 1, 11. Likewise, it is storing, for example, at 13th position, it will store the sum of 1 to 13. So that if we want to access a range like from 1 to 8, what is the sum? We can directly go to the 8th index and pick the sum. So the sum from 1 to 8 is 29. It will be that easy. Not just from index 1 to any index, also can be calculated from any range. Like for example, if we want to calculate the sum from 6 to 8, what we are going to do, we are going to take the sum from 1 to 8 and subtract the sum from 1 to 6. That is, we are going to take 29 and subtract 16. So if we subtract 29 from 16, we will get 13. That is the sum from 8. 8 plus 2, 10. 10 plus 3, 13. So we got the sum from the range 6 to 8. That we can represent as sum of 0 to j will be t of j. At that position we can take the sum. Or from any range I comma j, we can take the sum and subtract what are the sum from before the index. So this is again a linear time algorithm which will take linear time to calculate all the sum and work on it. To reduce this, for example, if we are going to change any particular value, here we are going to change 8 to 10, then we have to update every value after the index 6 here. So the value changes by 2, add by 2, we have to add 2 at every value after the 6th index. So that is again a linear time algorithm. So to make use of this algorithm in an efficient way, they are dividing the tree array to 2. If you see, they have two t arrays, that is t1 and t2. Now they have calculated the sum from 1 to 7 in t1 and 8 to 14 in t2. So the sums are different. So if you want to calculate, suppose from the in range 6 to 8, the first array is having the range 0 to 7 and the second array is having the range 8 to 14. We want the sum of 6 to 8. So our total sum is there in 7 and we have to add the 8 as well, but subtract the rest of the sum from 1 to 6. So we are taking 27 minus 16 plus 8. So this will give the sum from 6 to 8, that is 11, and this will give the sum of 8th position 8. So what is the advantage of this? If suppose I am going to change the value of 7 to 10, so in that case I have to change only this number to plus 7. Other than that, no changes will be happened in this t2. So that again the same thing will come, and 34, it will change to 34 minus 16 plus 8. You don't have to change each and every value after that position. So they took this idea and they further divided the arrays into much smaller and smaller until they get a proper solution like this. Now we are splitting our array like this. Let me explain why they are placed like this later. Now let's see. The array 1 of 1 is having here, and 1 comma 2, from range 1 to 2 the sum is 8, and from range 1 to 4 the sum is 11. The 3 is alone here. I'll explain the structure later. And if you see 5 comma 5, 5 value is here, 5 comma 6 is having 13. We are adding only the range 5 comma 6, and 1 comma 8 is here, 7 comma 7 is here, 9 comma 9, 9 comma 10. This will add these two numbers like that we have placed. So for example, now our goal is to find the sum of a range. For example, we want to find the sum of a range 0 to 13. So 13 can be represented like this: 2 power 3, that is 8, 2 power 4 is 4, and 2 power 0 is 1, equal to 13. So we can represent it this way. So first what we are going to do, we are going to take sum of range 0 to 8, that is first 8 numbers, and then sum of range 9 to 12, that is next 4 numbers, and the sum of one number 13. Let's see. Now we want to have the sum range from 0 to 13. So first, as we said, we are going to take the number 1 to 8, and then we are going to take next 4 number 9 to 12, and then we are going to take next number 13. So the total sum will be 29 plus 10, 39, 39 plus 4 is 43. So the sum from range 0 to 13 is 43. If we check our previous array, the sum of the range is 43. So for example, if we want to take the sum of 5, so from 0 to 5, how we represent 5? 2 power 2 plus 2 power 0, that is 4 plus 1. So what we are going to do, we are going to take the sum of first 4 numbers and then one number. So we are going to take the sum of first 4 numbers, that is 11, and then one number, that is 5. So 11 plus 5 is 16. The sum from range 0 to 5 is 16. Let's check. So yes, it is 16. So that is how we arrange our numbers and find the sum. So let's see. Yes, to find the 13th sum from 0 to 13, we are first taking this and then going to the next 4 number and then going to the next 8 number. This is how if we want to find the sum of any index, we write it in the form of 2 power n and then find its parent. So why these numbers are arranged this way? Let's see. We are representing these numbers 1, 2, 3, 4, 5, 6, 7, 8 in binary form. Right? So for example, how to identify its parent, any number's parent? So consider this example again, number 13. Number 13 we represented as 2 power 3 plus 2 power 2 plus 2 power 0. So first we are taking 2 power 0, that is the 13th element, that is 1101. How to find its parent? Just right flip the last bit, that is 1101, flip the rightmost bit. Here the rightmost one is here. We are going to flip it 1100 until the number become all zeros. So its parent is 1100. See, 1100. So we are adding 10 plus 4. Now we are going to flip the rightmost bit. Here the rightmost bit is the 1 at the second position. So it is 1000. So its parent is 1000. So we are adding plus 29. Again we are flipping the rightmost bit. It is 0000. We don't have that index, so it is ending here. for example, we are going to find the sum of 0 to 7, that is from 0 to 7. Let's see, the 7 can be represented as 111. So here's the 7. What we are taking the 3, so its parent will be flipping the rightmost one. So flipping this 1 will become 110. So its parent is this. We are adding the 13. So what 110, if we flip the rightmost number, it will become 0100. So 0100 is here. So we are adding one more 11. So this adds to 27, right? Let's check what is the sum of 7. Yes, it is 27. So that is how we find the parent. So how to do that in a code, or how to find its parent? If we see normally, we can right flip the last element. So how to feed that to a in a program? So to do that, we are having 3 steps. These steps are used to flip the rightmost one in a binary representation of a number. So first we are going to do a 2's complement to a number. What is a 2's complement? Suppose a number is 1100. How to do a 2's complement? We gonna reverse all the numbers. That is, if there is a 1, we are going to put a 0. If there is a 0, we are going to put a 1 and add a 1. So it will become 10, again 10, 1, 1. So this is the 2's complement of a binary number. That is, we are going to flip all the numbers and then add 1. So again, AND with its original binary number. So original binary number is 1100. So we are going to AND with its number. So it will be 1100 again, and we are going to subtract it from its original number. So we're going to subtract it from the original value. Let's see it with an example. We are taking 13. 13 is represented as 1101, and we are going to take the 2's complement. So 2's complement can also be represented as a negative number, or we can say a negative number of any number will be represented as a 2's complement in binary. We are taking 2's complement, that is all zeros are replaced with ones, and here also it will become 00, but by adding 1 it has a 1 at the end. So this is how we represented a 2's complement. So we are doing an AND here. AND operand will get you this value, that is, where there is only 1 and 1, there will be a 1, otherwise it will be a 0. So finally we are going to subtract it from the original number. So this can be represented as 1 in decimal value. So the original number is 13. 13 minus 1, 12. So if you observe the binary number of 12 from 13, the rightmost bit is changed, that is 1101 is replaced as 1100. So by following these 3 steps, we have changed the bit to 0. So now it has said we have to take the 13th value, and then we gonna go to the 12th value. Now we are taking the 12th value and repeating these 3 steps. See, now we just took the 13th value and it went to the 12th value, that is 1100. It added this value as well, 4 plus 10. Now it is gonna repeat the step for this binary number and find its parent. See, the binary number for 12 is 1100. We are taking the 2's complement and we are doing the AND operation to get 100. The value is 4. So when we subtract 12 from 4, the value is 8. If you observe the binary number of 8, the rightmost one from 12 is being flipped here. This number is flipped to 0. So the next parent is 8. So if you see, 8 has having the value 29. So we are adding 4 plus 10 plus 29. So 43 is the sum we found. Then if we further do the same steps to 8, it will flip this element and becomes completely 0, then it becomes invalid. So that is how we are going to find the parent value and calculate the sum. Okay, so how this algorithm will store the values. For suppose if we take 3, only 3 is stored. For if suppose if we take 6, it has the sum of 5 and 6. So how this algorithm determine which range should be calculated and stored in these boxes. Okay, so first let us see what are all the numbers is having single values of that particular index. 1 is having a single value of 1. 2 is having from range 1 to 2, and 3 is having its single number, and then 4, 5 is having a single value of that index, and then 6, 7 is having that single number, and then 11, and then 13. All these indexes are having their own single range values. So if you keenly observe, the common thing in all these indexes are the last bit is 1. See, in 3, 7, 11, 13, and this number, in all these indexes the last bit is 1. So now if we observe the binary numbers having 1 at last but one position, that is this number and this number, this number, and this number. These numbers are storing the values of ranges 2. For example, if we consider this number, it is storing the value from 1 to 2, and this number is storing the value from 5 to 6, and this number is storing the value from 9 and 10, and this number 13 to 14. Let's look at this representation. This is our array A and this is our array T. Now let's see how from array A the array T is calculated. As I said before, the numbers are the number at last bit 1 will be filled with one value. For example, this one has the value 1, and we are having the last number 1, and here it is 3. So again we are having 1 at the last bit here for 5 and 5, and here for 7 the value of 3 is transferred directly, and for number 9 transferred directly, number 11 transferred directly, and number 13 transferred directly. So the binary representation should have 1 at its last bit will be directly saved without any changes or adding with any other value. So now look at the numbers having 1 at their last but one position, second position from last. So that will add the range of 2. So adding 1 and 2 will be going here, that will be 8. So, and if you see the number at 1 at the last but 1 here, so this will add range from 5 to 6 and will be saved in this box. And finally this one is having, so the range 9 and 10 will be added, and at last 14 is having 1 at the second last but one position, so these two numbers will be added and stored here. So our T will look like this now. So this and this value and this value, same way. So now these empty boxes will be filled with range of 4. Let's look at a binary number having 1 at its third position, that is third position from last. So if you see, this number is having number 1 at its third position, so this will calculate the range from 1 to 4, that will be added and stored here. And another number having 1 at its third position is 12, so this will add from 9 to 12 and store the value here. So this box is filled and this is filled. Finally the only empty box is this. So if you observe, that is having 1 at its fourth position. So this will add the range from 1 to 8. This will add, and the final array T looks like this. So this is how the numbers are calculated according to the position of 1 and placed in the array T. Now suppose if we want to calculate the range from 0 to 7. So 7 is represented as 111, flip last one number and it'll be 1110, and flip last one number and it'll be 0100, and flip last one number it'll be 000. So we have to add three values, that is value in number 7, that is 3, value in number 6, that is 13, and value in number 4, that is 11. This sums up to 27. So this is how in a Fenwick tree or a binary index tree the numbers are calculated and stored in a new array and the sum will be calculated. Now we are going to see how we are going to represent that in a code. So the main concept is finding the parent of index. So to find the parent of the index, we have seen these three steps: finding the 2's complement and adding an and subtracting it from an original number. So that can be represented like this. That is, if a number is passed, then until the number becomes 0, we are going to calculate that number minus number, and minus here represent 2's complement of the number. So this is the code we are going to use to find the flip or the parent of any index. So now let's see an example problem that can be solved using Fenwick tree method. So here in LeetCode, today's problem is create a sorted array through instructions. So in that problem we are given an array instructions and we have to calculate the cost it takes to sort the array. For this problem we are given a integer array with numbers. Now our job is to sort the numbers into a new array called nums. While we sort the array, for each element there will be a cost. So how a cost is calculated is, for example, if we are taking a number and entering and putting it to the numbers array number 1. So for that first number, it will check in numbers array how many elements are less than that number and how many elements are greater than that number. So it will find the minimum of these two values, and that will be the cost of that, cost of inserting that number into the nums array. For example, first consider the first number, num equal to 1. We are going to put that num into nums array. Let's check how many numbers are greater than num and less than num. There is no numbers greater than num and no numbers less than num. So it will be 0, 0, and the cost for putting the number 1 into nums is 0. So let's see further elements. So in our first we inserted 1 and the cost is 0. Second we are going to insert 5. Let's check how many numbers less than 5. The number less than 5 is 1 and there are no greater elements than 5. So it is 0. So minimum of 1 and 0 is 0. Again the cost is 0. Next element is 6. The numbers less than 6 are 2 and greater than 6 are 0. So the cost is again 0 because the minimum of 2, 0 is 0. We are going to put the last element 2. Here if you check, the numbers less than 2 is 1 and the numbers greater than 2 are 5 and 6. So minimum of 1, 2 is 1 and the cost is 1. The total cost used to insert all the elements here in this array nums is 1. So in our algorithm we are going to use the same concept of Fenwick tree to calculate how many numbers are less than a number inserted and how many numbers are greater than the numbers inserted. For that we are going to use a count array. This array is going to have the keep track of how many numbers entered are less than that number and how many numbers entered are greater than that number. So let's type in the algorithm and see. as I explained, I'm gonna declare a count array to keep track of the numbers. And since if you see, they have asked us to return the number in modulo 10 power 9 plus 7, we are going to the numbers are in higher format, so we are going to declare two other variables. The first one is limit, and we are going to declare that as an integer, so 1 exponential 5 plus 1 is the limit, and mod, as they said, we are going to declare the mod as 10 exponential 9, sorry, 10 or 1, 10 power 9, so, and the limit they said is 10 exponential 10 power 5, so we declared as 1 exponential 5, and the mod is 1 exponential 9 plus 7. Now I'm going to declare a variable total cost, that will be the output we need to return, and we are assigning the array of limit, because that is the limit they are mentioned in the condition, so we are declaring the array to that limit, and we are going to put a loop to iterate each and every element from the instructions array. Now, as I said, we are going to calculate the total cost by adding the total cost with minimum of min value comma max value. Right, and we're gonna return the total cost by modulo of the mod value, that is 1 exponential 9 plus 7. So this we understood. Now we are going to calculate the min value and max value. So we are going to put a helper method, that is we are naming it help get count. We are going to call the numbers before instructions of I, because if we are passing the numbers before instructions of I would be the lesser number than that number, and we are going to calculate the max value by negotiating the numbers till that index. Because these numbers would be lesser than the number. So okay, now we have a method, helper method, to call the values and calculate the maximum and minimum, and the total cost will be calculated, it will be modulated and then returned. So now let's the get count method. We are going to return integer value, minimum value, maximum value, so we are mentioning the return type as integer, and we are declaring a method variable result. I said we are going to iterate the number till it becomes 0. So result, now here the check is we are not going to calculate the values inside the array. Instead we are going to calculate the indexes, that is how many indexes are carrying the numbers less than that number. So that we will calculate how many numbers are less than the number or how many numbers are greater than the number. So we have declared a count array to keep track of that. So what we are going to do, we are going to count the numbers, how many numbers are less than the number. Then as I explained, the number, we can flip the last bit by using this concept, number and 2's complement of that number. Then we are going to return the result. Okay, now we just called the get count method to calculate the minimum value and the maximum value and calculate the cost, and we are going to return. Now there is a thing called count number. We have to update this array in order to keep track of the count. So how we are going to do that? For that we are going to write another method, update count. While the number is less than limit, count of number will be plus and number I'm going to call this method from